you're doing great. In this video, we want to talk about how we can balance chemical equations by oxidation reduction. But first, let's see what is oxidation reduction. Oxidation in definition means loss of electron by atoms, and reduction means gain of electron by atoms. But oxidation numbers is the number of electrons that atoms use to bond with other atoms. There's some rules for oxidation number that you see here. For example, whenever you see hydrogen in equation, the hydrogen oxidation number is always 1. The oxygen is always -2, which makes sense because, for example, if you think about the compound of H2O, water, you know that oxygen has -2 charge and hydrogen has +1. 2 times of +1 will be +2, and 1 time of -2 is -2. These guys cancel together. So at the end, we will have water, which doesn't have any charge. So the F is always -1. If you see any ions, for example, you see, chlorine -1, you see that, okay, the oxidation number of this is -1. And when you see the uncombined elements, for example, you see O2. O in a compound like H2O is -2. However, O2 in gas form is equal to 0 because it's not ready to bind to anything. Group 1 metals will be +1, group 2 metals will be +2, which is exactly their charge if you think about it. Do you remember this last equation we have done in balancing equation video? So this here, we want to do the easier one. First, let's figure out the number of electrons that atoms use to bond, or the oxidation number. So as we see here, all of hydrogens should be +1. So that's why you see that all hydrogens here and here are +1. All oxygens are +2. You see, whenever we have oxygen, I have written +2. Whenever we have compound which doesn't have any charge, is not in a compound, is equal to 0. However, zinc here is in a compound. It is in a compound NO3, 2. Okay, that you know that this here, the 2 here shows us the previous charge of the ion of zinc that before compounding to NO3. So here is +2. So you know that zinc is one of those atoms that changed its oxidation number. For balancing, we want to use the atoms that their oxidation number changed. So zinc will be one of them because it changed from 0 to +2. No oxygen change here. Whenever you see it's -2. However, we don't know anything before doing equations about nitrogen because nitrogen is not one of these rules that you see here. So we have to calculate the nitrogen. How we do it, we should remember that the sum of actually oxidation numbers of atoms in a compound is equal to 0. For example, the HNO3 should be 0. You know that H is +1, so 1 times 1 plus N that you don't know plus 3 times -2 should be 0. 1 plus N minus 6 is 0, so N is +5 here. So N is +5. N in NO3 is +1. Here we have NO3, so here N is again +5. It doesn't change. However, in this compound, which is just NO, that we know O is -2, plus N that we don't know should be equal to 0. So N should be +2 here. So now we can say that N has changed from +5 to +2. As you see, the oxidation number of nitrogen decreased from 5 to 2, but for the zinc, it increased from 0 to +2. So I rewrite the equation again so we can do better here. I write only the ones that we needed, which is zinc and nitrogen. We want to balance them. We have -3 here, we have +2 here, but that doesn't work. We need to have same number, so you multiply top by 2 and bottom by 3. In this way, you will have 6 electrons that are changing. So now that you have multiplied that by 3 and 2, you know that you should add 3 here because you have multiplied your zinc by 3. So if this is 3, obviously this is 3 too. For the next one that you had 2, you're going to have 2 here because you multiplied by 2. So now that you have this 3, 2 and 3, actually you have all the N's, nitrogens, all the zinc, and you can do the rest of so easily. So you have figured out the 3, and the 2. So it means that you know all about N's and zinc and also hydrogen because you already know about oxygen too. So here is going to be 8. This is going to be 4 because we have a hydrogen here.